Hello everyone, this is assignment 2 and today we would be analyzing data related to the insulations material industry. As we can see, we have the standard orders and blocks and center points already. Plus we have this data. We would have a look at it through the descriptions just now. So the description goes as follows. A materials engineer for a building products manufacturer is developing a new insulating product. The engineer designs a two-level full factorial experiment to assess several factors that could affect strength, density, insulating value of insulation, and so on. Uh, this is the description basically. These are the orders which have been defined with the data. Blocks, there's only a single block. Material type, which can be Formula 1 or Formula 2. These are three other variables, which is injection pressure, injection temperature, and cooling temperature. As you can see, all three of them uh, have a high-low format, which is they have only two values and their values actually matter. So we would look at these, and we have measuring temperature is given that it is a covariate. Insulation density and strength, which are the resultants, are the response values, and machine that creates the insulation is again a variable. Okay, and now we would look at the data again, and now what we're going to do is we are analyzing this design of experiments. So firstly we'll have to define it. Let's go to stats, DOE, which is design of experiments, factorial. Create factorial works when you have to create factorials and then enter value, but when you have already entered the values, you just have to define the custom factorial design. So what are the factors we have? Yeah, these are all two level. So enter the factors. The factors are material, inch press, inch temp, cool temp. That's all. High, low, let us see if those are okay. This is text, so it will not count this as a value. All the values are correct. Okay, now we go to designs. We would specify all three, which is order, run order, and center point. Okay, let's do that. Standard order, run order, and center point, although it does not have any, and blocks, just take it as one block. Okay, and now we have defined this design. Now let us go and to process and analyze this design. So again we have to go to stat, design of experiment, factorial, and then analyze factorial design. What are the responses? Let us see this. The responses are these three: density, strength, and the insulation. Okay, this is insulation, density, and strength. So now we would move on to the analysis of this design. That will basically go to stat, design of experiments, factorial, and analyze factorial design. So the responses we have to choose are insulation, density, and strength. The covariates would be nothing but measuring temperature. We have selected all those. We'll select the type of responses that we want. Now we're choosing all the responses, and graphs. You can check for whatever we want. We can have standardized plots, we can have residuals and individual plots. Okay, we don't want a normal plot, and that should be it. We are also going to have a Pareto plot which would decide. I think everything here is done, and now we would move on to look at the analysis tables. Pareto chart for the three responses expected to be first, and we can see that the effect is most pronounced, is the most prominent for factor A. And then moving on, the interactions probably not so significant. It's the first one. Now we'll look at for density. Density factor B, which is the injection pressure, is the most significant. Now we'll see the third one. Again, the material is most significant for insulation. So the property of insulation, we'll put them side by side. Probably I don't have so much space, so you can see for insulation and strength, material was the most significantly affecting factor, and for density we had that injection pressure was the most affecting factor. That was one of it. Now let us look at what other things have been done to it through this. So this is the regression equation for strength. Strength is one of the most important properties for a insulating material. So you can see on the screen, strength depends on 20.64 is the constant, and now minus 0.5038 into measuring temperature. This means that it is inversely dependent on the measuring uh, on the measure of temperature, and plus 3.56. So when you go from material 1 to material 2, this increases by a value of 31.56, and injection pressure, probably for every unit of injection pressure it increases by a value of 0.35, and so on. We have all the interaction effects also. Now let's look at a graphical analysis. So we'd move on to DOE factorial. So we would use the same created design. Now we would draw a surface plot. As you can see in the description, the plot is a relationship between two continuous predictors and a fitted response with a 3D surface. Injection pressure, injection temperature, and the response strength. Let's see what happens. As you can see here, the surface is at the highest point. I mean, the Z value, strength is the highest, and injection pressure is the highest, and this is injection pressure, and even the injection temperature is highest. So it is actually corresponding with the regression with which we saw. So the signs of the regressions. So let's close this, and as we can see, Minitab can be used for a variety of operations. This one was the insulation industry data. We have done a design of experiments analysis, and we've used the least possible or the optimum number of experiments to analyze the maximum what we can from this data. This would be it for this presentation. Thank you, and see you later.